Hi guys, in today's video we'll be talking about matter. We did some brainstorming about matter in our last class, but today we'll take some time to make our definition more formal. From our class examples, we learned that matter is anything that has substance and takes up space. They're physical things. You could hold them in your hand if they were the right size, or you could touch them. If we want to make this definition a little more scientific, we can borrow two words from physics, mass and volume. So if something has substance, really what it has is mass or weight. And if something takes up space, that's just volume. So we could alternatively define matter as anything with mass and volume. Just as a reminder, some things that are matter that we talked about in class are sunscreen, bacteria, Air Jordans, air, or Beyonce. We can touch all of these things, even if just on a theoretical level. Let's take a minute to delve a little bit more into mass and volume. Very consistently with what we just talked about, mass is how much substance is in an object. Some people use mass and weight to mean the same thing, but weight takes into account gravity where mass doesn't. So as scientists, we like to use mass to be more precise. We usually measure mass in grams, milligrams, or kilograms. In the English system, we usually measure weight using pounds or ounces, but in science class, we'll be using these measurements instead. When we want to take the mass of something, we'll use a balance or a scale. Here are the ones in our lab that we'll be using.
The black scale can be used to measure objects that weigh 1,000 grams or less, while the blue scale can be used to measure objects that weigh 200 grams or less.
Because different balances are set up differently, you just want to be careful which one you're using based on the weight of the object you're measuring. Our second quality of matter is volume, which is just the amount of space an object takes up. Right now my dog Benson is pretty small, so he doesn't take up a lot of space. Right now he's sitting in the armchair quite comfortably. But I know that in a couple months he'll take up a lot more space. Hopefully he still fits in the armchair, but I'm not so sure. When we want to measure volume in the English system, we might use cups or gallons, but in the metric system, we'll use liters, milliliters, or cubic centimeters. 1 milliliter is the same thing as a cubic centimeter, but because both are commonly used, I want to teach both of them to you. Cubic centimeters are often used in medicine, and we'll be talking a lot about dosages later this year. If you'd like to measure volume, usually we use a graduated cylinder. Just like with the balances, certain graduated cylinders are set up for certain amounts. So the smaller one only measures 10 milliliters, while the larger one measures 100 milliliters. You could also use a beaker to measure volume, but they are not very accurate. Another important thing to consider with matter is the phases that it takes. The first phase we'll talk about is solid. For every phase of matter, we're going to talk about three properties: their shape, volume, and whether or not they flow. Solids have a fixed shape and volume. If we look at the molecules, they have very little energy. They can't move around, they just kind of pack together and shiver or vibrate in place. If you push on them, you'll move the whole thing, but you won't be able to move individual molecules. Because they don't have the energy to move, they take up the same amount of space all the time. And they don't flow. They're not moving around on their own. Some examples of solids are your iPhone, your textbook, or a coffee cup. Liquids have a fixed volume, and they take the shape of their container. When we look at the molecules, they have enough energy to wander around the bottom of the container. They'll take the shape they're given, but they'll flow around on the bottom. They'll also flow from container to container if they're poured. Think about water in a tall, thin vase. If you pour it into a shallow bowl, it will now have a new shape, the shape of the shallow bowl, but it won't have any different volume. You'll still have the same amount of water. And that pouring motion is the flowing that we're talking about. The molecules are still in contact with one another, but they're able to move against each other if they're given a little help to take up a new shape. Some examples are water, orange juice, and molasses. Even molasses, which are pretty thick, are still able to flow. Our final phase of matter is gas. Gases take the shape and volume of their containers. If we look at the molecules, they have lots of energy. They have so much energy that they literally bounce off the walls. They move in the whole three-dimensional space that they're given. Even though we don't see them flow as easily as liquids, they're still doing it. If you have a window open in your room, the air in your room and the outside is flowing back and forth. Some examples of gases are air, steam, which is just gaseous water, and nitrogen, which you might find in your scuba tank.
We'll use two different sets of properties when we're describing matter. The first set is chemical and physical properties. Physical properties are properties that can be observed without changing the matter. So these are things like the appearance of an object, the texture, the color, or the density. You can see what color something is without needing to change what that thing is. To contrast that, we have chemical properties. Chemical properties describe how some kind of matter reacts. So, for example, you can light something on fire and see how flammable it is. However, when you do this, you're changing what it is. You're taking it from that substance into smoke and ash. So, unlike physical properties, to observe a chemical property, we need to change what the matter is. Other chemical properties include what a substance will react with and how reactive it is. So for example, if you put a small piece of lithium in water, it will fizz and smoke. But if you put the same sized piece of potassium in water, it'll explode. The other set of properties we use to describe matter are extensive and intensive properties. Intensive properties don't change with the size, shape, or amount of substance. They include things like color, hardness, density, shininess, and odor. So if I see a white liquid in a glass, I'm going to identify it as milk based on its color, or perhaps on how it smells. I like to think of the I in intensive as like the I in identify. These are properties we can use to identify what kind of matter we have. Extensive properties change depending on how much of the substance we have. So that's something like mass, volume, height, or width. If I think about a granite stone versus a granite boulder, they'll both have the same hardness, color, and density, the same intensive properties, because they're made out of the same material. But because one is a stone and one is a boulder, they'll have different heights, different masses, and different volumes. That's it for today. Please write any questions that you have in your notes and we'll chat about them next time in class.